Was it? Sorry. You guys are hilarious. The end. That's his trumpet sound. Beep, beep, beep. Okay. It's a little time done. Anyway, isn't there some weird, there's a weird Netflix movie about, like everyone wore watches and it was counting. Anyway. I don't even know what it was called and it wasn't that great. It was from a long time ago. They do much better movies now. Was 5 minutes a little ambitious? For those of you just joining us, we just took 5 minutes, like a little speed drill, to see how many factoring people could do. Was 5 minutes a little ambitious? Probably. Probably. Yeah, it takes time, right? So some of you are like, yeah, I did one. Okay, your goal is to be able to do more than one in 5 minutes. But maybe you were able to do more than you thought you were. Maybe you were able to do less than you thought you were. Here's what I want you guys to do in your groups right now. I want you to check if you got stuck or if you just ran out of time. First of all, collaborate. Did you get stuck or did you just run out of time? And if you got stuck, reach out for help and be like, so, how do you do this kind again? And if you didn't get stuck, if no one in your group got stuck, check your answers. You should all be the same. And if someone has a different answer, foil it and figure out who was right. Okay, check answers. How many did you get? First, give a high five to whoever got farthest. Give a high five to whoever got farthest. And I'm going to solve them all, so you guys go. Here, we'll time me and see. Let's count up. We'll see how long it takes me to do all of them. I don't. I know that it's 7x and x to make 7x squared. There's no other way. But I just went through 20 and 1, 20 and 1, 10 and 2, 10 and 2, 5 and 4. Oh, it worked. I was doing outers and inners. So I tried 7 and 20 is 140 and 1? No. 7 and 1 and 20 is 27. 7 and 10 is 70? No, there's no way. 7 and 2 is 14, 14 and 10? No, it doesn't work. 7 and 5 is 35 and 4? So it's basically what you guys are doing with the 140 and figuring out factors, but I don't have to go to the 140. I'm just doing little outer inner trials. Oh, hold on, pause. Wait, I'm trying to finish mine. Give me a second. Right now I'm doing 28 now times 7, that's gross. I'm doing 7 and 4, so 7 and 7 is 49. Ooh, 49 and 4, I like that. 49 needs to be negative, 4 needs to be positive. 2b and b. 21 and 2 is 42, gross. 21 is 3 times 7, so 7 and 2 is 14, 14 and 3, I like it. 18 and 5 is way too big. 5 and 18 doesn't work. 2 and 9. 9 and 5 is 45. Ooh. 5 and 2 is 10. 10 and 9. That's great. I want 10 to be negative, 9 to be positive. Ugh. Nope. We're going to pull out stuff first. 4 comes out of everything. 16 does not. 4n squared. Didn't we just do that one? Oh. Oh, no, we didn't. $20 and 7, no. 10 and 7, 70, no. 2 and 7, 14 and 10, yeah. 14 is a positive. Okay. Three minutes and 20 seconds, and I got slowed down for a second. Nice, but am I doing the X method? No, this is from years and years of guess and check method, getting really good at it. Yeah. How'd I do it? I got my 7x and x. I thought 28 and 1 first of all, but 28 and 7 is way too high. 7 and 28 wouldn't get me, because 7 and 1 and 28 and 1 wouldn't get me to 45. So then I broke it down to 4 and 7. 49x, negative 49x plus 4x is 45. Yeah. Now, I'm not going to do I'm not going to do modified x on every single one, kiddos, because it would take a lot of time. But let me do it on at least a couple to remind you of how you could get to the exact same place my guess and check method is getting. But Jordan, first a question, and then if you guys want to look at the ones that you got stuck on, you might not have finished, and that's okay. Go tonight and practice your factoring a bit more. You have the answers you can come back and look at any point in time to practice your factoring a little bit. But Jordan, go ahead first. What's up? A number in front? Sounds good. Yeah. I actually want an example of each. So let me do number 5. Does anybody want 1 through 4, one of those? You didn't get it right? Or you got stuck on it? Does anybody just naturally get stuck on something 1 through 4? Are you sure? We're okay? Okay, I'm just making sure. So is there anything else? Let's do 7 through 10. Is there one of these you want me to do a modified X method on? Which one? Okay, yeah, it's gross. But are we okay with pulling out the GCF first? No matter how you do it, you have to pull out 4n squared, or else we're sunk before we start. Okay, yeah. Well, the problem is to factor completely, and I didn't put directions, Lauren, so that's a little bit of a struggle. But my directions would be factor completely, so go as far as you can. As far as you can, as far as you can, as far as you can go farther. No, because it didn't say find the zeros. So it wasn't, some of you might have kept going, like x equals 9 and negative 2. That wasn't the goal. The goal was just to factor. Does that make sense? But if they said find the zeros, or find the intercepts, or find, eventually they could use the word solutions, then it would mean, oh, set equal to 0 and keep going. Okay, so modified x method on number 5, and then number 10, and then we'll move on. So modified x method, that's what Mr. Che calls it, right? Page width. Here we go. Why is he modified? Why is he harder than 1 through 4? I totally agree. Well, number 6 hopefully wasn't harder. But number 5 and 7, 8, 9, and 10, they were all harder. Why? Oh, you guys know. Why is it harder? There's a number in front, right? There's a number in front. So when you go to do your x, remind me really quickly, what goes in the top spot? What goes in the bottom spot? Okay. So if you do a times c, if you do the b, first of all, we have to get these numbers. First things first, we have to get these numbers. But even after we get these numbers, this is what a few of you guys get confused on. This is where you make mistakes. Even after we get those numbers, when you're doing the 7x squared, you cannot go straight to the answer. As soon as you have a modified x, a is anything other than 1, you cannot go straight to the answer. You're going to have to split this guy up into the 2 x terms. I could call him, for instance, I could call him like a d and call him like an f. A, B, C is already taken. E is actually a special number in math, 2.71828, so I'm not going to, 2.71828, so I'm not going to use him. But I could say we need to split this guy into 2 different little x terms, copying down the c and copying down the ax squared. And then we do this process called grouping. That's the goal. But we can't even do this until we figure out who d and f is. So I'm looking at 140 and I'm saying, okay, divide them in half, but is 2 and 70 going to cut it? I have to divide them by a whole lot more than that. So I'm going to go dividing by 5. 5 goes in my head, in case you guys are wondering mental math, because we're trying to master all sorts of things this year. In my head, I'm saying 5 goes into 14 2 times. 5 goes into 48 times. That's how in my head I would get 5 and 28. 5 and 28, how does that go? It's close, right? But maybe I went a little too far. 5 plus 28 is just a little bit more than 31, and I can't add these two together because I need opposite signs. I need to subtract. Maybe I need to divide by 4. 4 goes into 14 3 times, right? Ooh, I like him. Do you guys like him? Yeah. So I'm going to use a negative 35, and I'm going to use a 4. But I cannot go straight to the answer. I'm only allowed to go straight to the answer when my little x method is just a 1 times c because the a is 1. Only then can I actually use my d and use my f and say, sweet, let's go straight to the answer, and I'm done. Only here. So my modified, or not my modified, it's just an x method. I would have had, for number 1, a negative 18. I would have had a negative 7. I would have a negative 9 and a positive 2. X minus 9, x plus 2. You're done. Only when you have 1 times c does that work. Every other time, like this guy, and number 7, 8, and 9, and 10, you have to take what you found in your table. I apologize, in your x. And you have to split this guy up and say, okay, well, you came from a 35x and you came from a 4x. Plus a negative 20. I literally didn't see the minus. Plus a negative is subtraction. What did I say a second ago about grouping? How do we do grouping? What do we look for? Factors that are shared, right? So what's shared between 7x squared and 35x? 7x. Don't we have x minus 5 left over? What's shared between these two? And why every time are we hoping these two match? Do you guys see what I got? Does it agree with what the modified x method gets? Perfect. I like guess and check too. But your brain, it takes practice to become good, efficient, and fast at guess and check. It's worth it, I think, but it takes work. Guys, how on any of these could you have double checked to make sure you were right? Or when you guys were checking in your groups, I was like, hey, just what? To see who was right. If you foil, what should happen? You should get the beginning problem. Yeah. Huh? Oh, you have your 7x squared. Got him. You have your negative 20. Got him. But you're forgetting your outer, negative 35x, and your inner, plus 4x. Oh, that's right. Negative 35 plus 4 is negative 31. Does that make sense? And that's why we split it up, because then we get the whole foiling, and we can go backwards properly. If we don't split it up, we have nothing to get to our original from in the modified x method. So then Jordan wanted number 10. I'm just going to skip there really quickly, and it gives us one more chance to practice the modified x method. Okay? Let me move my timer out of the way. Okay, you guys agree with the whole pulling the 4n squared out, right? Let me move him off to the side. This is what I thought it was. Unless you foiled, technically you don't know for sure that that's right. So let's go ahead and check it with the modified x method. Don't look at him. That'd be awful. Look at him. Who goes in the top spot? There you go. Negative 20 times 7, so negative 140. What goes down here? We already did a lot of factors of him. 140. Some teachers would have you do this off to the side. 1 and 140, not going to cut it. 2 and 70, not going to cut it. 3 doesn't even go in. 4 goes in. We just figured that one out. 35 times. Thanks. We already figured out 5 goes in 28 times. Man, anything getting us to 4 yet? In order to get to 4, don't we need the numbers really close together? So maybe dividing by 1, 2, and 3 wasn't such a great idea. Let's keep going. Anybody getting a little bit tired of dividing by stuff?
Yeah.
Okay, let's go to 10. Ah, 10 goes in how many times?
14.
Oh, that's nice. I know. I cheated a little bit, but I didn't want to do 6, 7, 9 just to get to 10. So 10 and 14. Do we like him? Yes. Which one's positive?
14.
Because I need the bigger number to be positive, smaller number to be negative. Now you guys help me. What do I do with the modified? It wasn't just a 1 with these two numbers. What do I do with those two numbers? I plug them in? Kind of. I would say I split up and then plug in, right?
Yeah.
But it's not an x term. What is it this time? So it's going to be 14n and negative 10n, and then you rewrite c and you rewrite a. And who's technically chilling all alone out here? Am I still going to group? Yes, I am. Why? It's the only way. I'm going to change the subtraction to addition of a negative. Otherwise, I just make all sorts of mess and kill some poor little seals in the way or along the way. I'm going to pull out a 7n to get an n plus 2. I'm going to pull out a negative 10. Remember, you divide by negative 10. That's n. Divide by negative 10 is plus 2. You can always double check with a little distribution. Negative 10n, negative 20. Good, good. They match just like I hoped they would, which means I did it correctly. And how's it looking? Good. Very good. Modified x method. Some of us need to still get better at factoring. Yes. Do you need to be able to do all 10 in 3 minutes and 22 seconds? No. Not even close. Would it be awesome if you could? Yeah, it would be awesome if you could. It'd be awesome if you could beat me with factoring and be right on every single one, not just be like guessing and being like, oh, look, good job. But the ultimate question is, can you get there even if it takes you a little bit longer? Matthew, what's up, bud? Almost. With the bigger number, look at number 10. It's not so much what number ends up being bigger in the factor, it's what x term ends up being bigger. So I needed the 14 to be positive because I needed the bigger number to be positive, but the 14 comes from the 2 and 7. So the 2 got the positive sign because it gets multiplied by the 7, which is 14 higher than negative 10. This guy, check it. The outer, negative 10b, the bigger term compared to 9b gets the negative. But it's not the bigger between 9 and 2. It's the bigger between outer and inner. Your trick only works. Oops, where'd the easy ones go? Ah, going the wrong direction. Your trick only works when you're seeing everything right away from the x method. Does that make sense? So in these ones, when you do the x method, the bigger one always, so the bigger one always. But it's because the outer and the inner are just these two already. But as soon as you go to modified x method, these are how the x term or where the x term came from, which was a combined effect of the outers and the inners. Does that kind of make sense? Good question, though, bud. Because you're right, it's a great trick, but it's only a great trick for this little guy. It's not a great trick for the modified x and for the factoring by grouping. Okay, let's get back into our notes. Sadly, the point of section 2.2, or maybe for some of you it's a good thing, isn't factoring. It's a part of it, but it's not the main point. The main point is standard form, the new standard form. Does anybody remember the one word I used to describe the ax squared plus bx plus c form from last year? Ah, that's what Mr. Che called it last year, but our book, we got to transition our thinking a little bit. It's not the new standard. It's the old standard, which I called, it is a quadratic, you're right. But technically they're all quadratics. They're just different forms. What did I call that old school? Ooh, we could just call it old school. What did I call? That's a great, actually, deli in Simi Valley. But anyway, old school. That's just polynomials. I want quadratics. Where is that page? There he is. What did I call him? That's the basic form. You can call him the old school form. You can call him the basic form. I think Mr. Che came up with another name for it. We were talking yesterday. What did he come up with? Oh, no, it was me calling it basic. Never mind. It was standard form last year. I'm so sorry. In some ways, shapes, and forms. Last year it was standard because this was the one you were able to work with the most. But this year we gotta move on. We gotta go deeper. We gotta get better. This is the standard form. It's a struggle. Last year we called it the vertex form. This year it's the standard. This guy's basic. This guy's old school. He's been replaced. Okay? So who's standard? And what's in him? Okay. So if you need to, you can think standard form. The new standard form is the vertex form. So sorry. That's a little confusing, but it is what it is. Didn't we write down these steps yesterday? I think we got all the way to adding in our special little term where we add into one blank to make everything balanced like we talked about with chem. We're going to have to add it in the other blank as well. We'll do some examples and hopefully make sure you guys master what's going on. We did talk about, you have that little cheater formula, h equals negative b over 2a. It'll always let you check that you've gotten your h right, which is kind of nice. But over here, keeping the equation balanced. In Algebra 1, when I taught it, I said add to both sides. It was easier in the brains for Algebra 1 to be like, what you add to one side, you add to the other. And that's good. But we know from Algebra 2, we almost always want y alone. So if we go adding to both sides, it's messy. If we can add and subtract from the same side, we're still just as bad. It's a little bit easier. So I like number 2, even though both of them are technically legal. And then step number 3, once you get the correct forms all nice and set up, once you have your perfect square completed, then you just need to factor and simplify. And the quick little note, oh, I put it up there. Huh. I put it in both spaces. Let me go ahead and change this then. Let's instead say you can check with hk being negative b over 2a f of negative b. If you're great at mental math, this will be the easiest way to go. You can almost ignore all of completing the square. But if you're bad at mental math, this is a horrible idea. Horrible idea. Absolutely unwise. Oh, I can't get rid of this little squiggle. I was trying to make it nicer and prettier. Lo siento. Okay, so the quick little note at the very bottom is, after this whole completing the square process, we can check with this little snazzy formula. And if some of you guys are really good at mental math, you can actually go straight there and ignore all of this. So some of you are like, I like the idea of ignoring. Let's go practice complete the square and see whether or not you should ignore the whole process or not. It all depends on mental math, but some of you, maybe you'll be fine. Struggle. Kiddos, you have the steps, right? Let me go ahead and get this page right next to this example so we can go step by step and follow, okay? Let's go there, and here we go. What's the very first step that we should do to this equation? Okay, all you have to do is read. We can do this, kiddos. Come on. No. Number 1. What's the first step? Okay, so why are we going to factor out an a if there is no a that's messing us up, right? The leading coefficient of 1, it's done. Don't factor anything out. Don't start doing the x method. The x method is great for zeros. For zeros, we would be like, yay. Why was I singing quadratic formula? Because quadratic formula gets you zeros. This is great for zeros. Am I trying to get zeros? Oh, I'm trying to get my vertex. I'm trying to get standard form. Standard form is not... Okay. So, let's come back over here. Get a leading coefficient of? Which is already? So let's move on. Step number 2. Okay. Is this a perfect square right now? No, because they don't match. Okay, so I have to make it a perfect square. Y equals x squared minus 7x plus blank. Even if you don't pull out an a, you still need to separate the x terms from the constant, because the 12 didn't cut it. You still need to separate the x terms from the constant. The 12 didn't cut it. He's great for finding intercepts, but I'm not looking for intercepts. I'm looking for the vertex. And, well, following directions of standard form. So what goes in the blank? What do I say to do to whoever's in the middle term spot? Some of you need words because the math is too confusing. You do half in the middle, half of the middle term, and square it. If you need the words and not the 1/2 times b minus a all squared, take half of the middle and square it. So, as some people are already saying, I'm taking half of the 7 and I'm squaring. Some of you love to go to decimals and say, that's negative 3.5. Square it in your head. Ah, stop. Most of them would freak out squaring 3.5. I would freak out. How fun is squaring 3.5? Anybody? Is that exciting? No. Most of us have to say, oh, okay, fine, squaring 3.5, right? Who likes that? Nobody. But square 7/2. What's 7/2 times 7/2? 49/4, no stress, right? Keep it in fractions, don't go to decimals. So, squaring 7/2, 49/4. Why am I saying a positive?
Because it's a square.
What you put in one place, since there was no a, I offset it over here. Now, some of you are still going to be like 12 and 49/4. This is stupid. I hate fractions. Okay, stop. It's not a big deal. Because look, we could change the 12 to be 48/4. Sometimes your brain just needs to learn tricks to make life easier. Why did I change 12 to 48/4? How did I change 12 to 48/4? Yeah. Well, not substitution directly. I mean, I did substitute, Matthew. You're totally right. But in my head, Jason was right. I multiplied by 4/4, right? So 12 times 4/4, 48/4 minus 49/4. Psh, that's going to be easy when I get there. However, as soon as you make your square, this step is supposed to be easy. How is it supposed to be easy? Remember yesterday when I had up on the board, and I should have erased honors pre-cal stuff so we had room to work. Remember when I squared a binomial, x plus a times x plus a? Remember what happened? X plus a times x plus a. What definitely did not happen? How does a puppy die? What did not happen? For sure, for sure. X squared plus a squared. That did not happen. Right? I have a puppy at home. I'm not going to go killing him here. Okay. X plus a times x plus a. FOIL it. We got x squared plus 2ax plus a squared. In this problem, whenever you fill in the blanks, you have an x squared plus 2a plus a squared. Every time you completed the square, you made it a square. So look up here, kiddos, and figure out a trick for your brain. If you have this every time you complete the square properly, what trick would let you jump back and say, oh, hey, he's the same thing as? Right now, I have a perfect square right here. How can you take these numbers and jump back to here? What pattern do you see about the a? Where is he down here? A could come from square rooting that, couldn't it? Couldn't you square root that number every time? Or what else could you do? How do you get a from this guy? You can always get to this, looking at this sign, which will be repeated, and either cutting that guy in half or square rooting that guy. Either one will get me a. So check it. When I come down here, and when I know that it's going to be a squared, when I know it's going to be x, when I know it's going to be minus, what number should go next? You have two options. Either cut somebody in half or square root somebody. Square root? Sure. What's the square root of 49? What's the square root of 4? That works. Is that the exact same thing we would have gotten if we had cut him in half? Wait, we already did this work, didn't we? Guess what's always going to happen? In completing a square, if you've done it correctly, you're always going to have the same thing as your perfect number that was squared. It's always, 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 always the same. Why is this so great? Because you end up with y is equal to x minus h squared plus k. Who's my vertex? Pull them out of the equation. Just waiting to be written. Who's my h? Why is it positive, Matthew? Not because of the squared. Careful. Because of the form. The form says x minus h. So who is it x minus? Positive 7/2. And who's my k? Why is it negative? Plus what? Oh, plus a negative 1/4. Not only did I get my standard form, which was the point technically according to their directions. They really said just standard form. Okay, I'm done. But I also got my vertex. Now, some of you were really interested when I said that whole, you can ignore this whole process if you can do this really, 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 really well. So who's this guy? And why would he let me ignore that whole process? Hey guys, from the very, very beginning, who was your A and your B and your C? From up here, basic form, old school form. Who was A? Who was B? -7. Who was C? Okay. To find a vertex, guess what? H equals negative B all over 2A. Oh my goodness! I already have him. I can put him in the H spot. My A is, there's A. But what else do you have to do? You need K. So the A, maybe that's not, sorry, the H is maybe not too bad, but what else do you need? And how do I find K? Well, I have an X value. Without any of this, I would have to go back and say, all right, y equals who squared minus 7 times who plus 12? You're going to have to deal with fraction math no matter what you do. The question is, how confident are you that you would get that right every time? For some of you, it's easy. For some of you, you could be like, oh, no big deal. I have 49/4. I have minus 49/2. I see a fourth, so I'm going to make that a 48/4. Oh, stink common denominator, so I'm going to multiply him by 2 over 2. I'm going to end up with a 49 minus a 98/4 plus a 48/4. And pretty quickly, I will get my negative 1/4, which is my k, and I'm going to say, ha-ha, I have h, ha-ha, I have k. I can plug in y equals a, which is 1, x minus h squared plus k, and be like, I know how to complete the square. But you have to get this right every time. And some of you, this freaks you out a whole lot more than just following a step-by-step that'll get you straight to the answer. Do you have an option? You have a choice. But just like guess and check in the modified x method, how they're both just as valid, you have to be able to do it right, or else it doesn't matter you trying to shortcut it. Okay, we have some more practice to do. We're going to pretty much practice till the end of class, I think. Actually, let's pause on the practice. Some of you guys need a break from the completing the square. And I wasn't going to do that one anyway. Yeah, let's go here. Let's take a break on factoring and completing the square just for a second to get some information down. Then we'll finish off class with one more complete the square. Pause. Give everyone in your group a quick high 10. Everyone. People are falling asleep. It's a struggle. I know. It's warm in here. The air hasn't turned on in a while. Give them a high 10. Not just a high five, they need both. Let's go, let's go, let's go, let's go. High tens, all around, all around. Come on, wake him up, pat him on the back. So you can do it. It wasn't just you. It's warm in here. I'm struggling. I'm the one standing and talking. Okay. Whew. Let's get down a page of notes. No example that you have to track with. Your brains get to rest just for a little bit as you write down a couple things about quadratics. Opening up, opening down, having a max, having a min. Who's the leading coefficient? What letter is that? Yeah. That's right. So leading coefficient A is positive, leading coefficient A is negative, whether it goes concave up like a cup or concave down like a frown. Positive people smile. Negative people frown. Anyway, there's a lot of ways to remember it. That was a gross generalization, by the way. Some very negative people are smiling and throwing daggers all along the way. But anyway, coming back. Right? You got negative people that smile. It's just not a nice smile. But coming back. Positive, negative, concave up like a cup, concave down like a frown. And beyond that, they both have vertices. They both have H's and K's. The difference is whether that H is a max or a min. And here's where it gets a little twisted, not in a bad way, not in a nasty way, just in a, your brain's not going to like it, and it's going to have to get used to it. If A is greater than 0, if A is max, nope. If A is positive, you're concave up, but your vertex is a low point, aka your vertex is a minimum. A smile has a min, a frown has a max. I think the difference between a valley and a hill. If A is negative, concave down like a frown, but that vertex is on top, which is a maximum. I know it seems so easy, hopefully. The vertex is a low, the vertex is a high, the vertex is a min, the vertex is a max. Hopefully that's easy, but your brain's going to get it mixed up just a little bit. The nice thing is every time they ask you for an axis of symmetry, even if the parabola gets all shifted all over the place, the axis of symmetry will always be x equals h. The same thing as the h, whether you use complete the square to get there or whether you use negative b over 2a. The axis of symmetry is always the vertical line x equals h. And to find the max or mins, if they ask you, all you have to do is just find the vertex. All you have to do is find the vertex. So quick reminders about when A is positive, concave up, when A is negative, concave down. But also now saying, oh, those vertices, sometimes they're positives, sometimes they're negatives. It all just depends. So with that, our last example of today is given a guy who's not super pretty as a parabola, not super pretty as a quadratic. They do want us to find the zeros, so factoring is going to be helpful, but completing the square is what we'll do first. And completing the square would say, very first step, get a leading coefficient of 1. But only taking away from the x terms. Now real quick, can anyone tell, when I'm trying to keep it balanced, why would I show a -2 blank over here if I'm adding a blank here? Yeah, I had to pull out a 2. So the blank is really a 2 blank that I have to offset subtracting over there. Do you remember how we take the middle term and cut it in half and square it? So I would add a 4 here and I would add a 4 there. 7 minus 8 is a -1. I can do that in my head pretty nicely, but I still need to say, hey, you're a perfect square, right? What perfect square will he be?
Plus 2.
How'd you get 2, Joe?
4 is...
Cut the 4 in half or square root the 4. Either way, you get to the same place. Oh, hey, who's my vertex? Ah, plus k, -1. Could you have done negative b over 2a and plugged it in and gotten the same answer? Yes, you could. Is that enough to sketch? -2, -1. Is that enough to sketch? Every parabola needs 3 points, but what if you set this guy equal to 0? And some of you might be like, I don't want to factor. He's gross. Pause, wait. Guess what? You can set completing the square equal to 0. And with some pretty quick math and some square rooting, we get to what the quadratic formula would give you. And as soon as you get these numbers, I think you might have just enough to go ahead and, with the zeros, sketch him. So, in homework, when it says sketch, you're putting together vertices and zeros and saying, there he is. All right, kiddos, get out of here. Thank you so much. If you're bad at factoring, if you're afraid of completing the square, come in. You'll get a whiteboard. We'll work together. It'll be all right. But don't just go home and cry. Let me help.